Welcome everyone. In this video lecture, we will solve a numerical problem on MOSFET circuit at DC. So the question is for a zero point 0.8 micron process technology for which oxide thickness TOX is given 50 nanometer and electron mobility 550 centimeter square volt per second. Find oxide capacitance, process transconductance parameter K and S, and the overdrive voltage VOV, that is VGS minus VT, required to operate a transistor having aspect ratio W by L 20 in saturation region with drain current ID 0.2 milliampere. What value of VDS needed? So this one is the question. So first of all, we have to write down the given thing. So the given thing are TOX 15 nanometer, mu n 550 centimeter square volt second. Okay, aspect ratio is also given, so I am writing here 20, and the drain current is given 0.2 milliampere. Okay, so the very first question, that is our COX. Okay, we have to find the COX. So COX is epsilon naught x by TOX, where this epsilon naught x is the relative permittivity of the relative permittivity of the silicon oxide layer of the SiO2 layer, and this epsilon naught x is 3.9 times of epsilon naught. Okay, so this value epsilon naught for the free space, this value will be 8.854 into 10 to the power minus 12. Okay, so if we solve, it will come 3.45 into 10 to the power minus 11 farad per meter. In the earlier video, in problem number 12, I have already discussed, but again I am writing this formula here. So epsilon naught x, that is our 3.45 into 10 to the power minus 11 divided by oxide thickness. Oxide thickness is given 15 nanometer, so it should be 15 into 10 to the power minus 9. So now what we will do, we have to solve this one. So one can easily write this as a 3.45 by 15 into 10 to the power minus 2, and if we divide 3.45 by 15, so the value will come 0.23 into 10 to the power minus 2, or in general we can write, if we write in milli, 2.3 into 10 to the power minus 3, and the unit will be in farad per meter square. Okay, so if we solve, this one will be the oxide capacitance. So the first portion, that is our, this one is our oxide capacitance that we have to find. So first we have calculated oxide capacitance, then after we have to find out the value of K and S. Okay, so K and S is nothing but simply a process transconductance parameter. So this value K and S is simply mu n Cox, electron mobility into oxide capacitance. So mu n value is given, so it is given 550 centimeter square volt per second. I am writing the full. Okay, and this one is 2.3 into 10 to the power minus 3 farad per meter square. Now unit is somehow different because here centimeter square, meter square. So first we have to change the unit. So as we know, 100 centimeter equals to 1 meter. So 1 centimeter equals to 10 to the power minus 2 meter. So for the 1 centimeter, one can write 10 to the power minus 2 meter. Okay, so what we can do here, we can write 10 to the power minus 4 meter square volt per second into 2.3 into 10 to the power minus 3 farad per meter square. So this meter square cancel out, and then if we solve, it will come 550 into 2.3 into 10 to the power minus 7, then farad per volt second. Okay, so this farad volt per second is what? So for this purpose, I just want to give a brief. This farad is the capacitor unit, that is our farad. Then C is can be C, or we can better to write Q equals to CB. So C can be written as Q by B. So why I am writing IV? So this should be ampere second by volt. So the farad unit can be written as ampere second by volt. So now this can be written, if we remove this decimal. So once again we have to go step by step into 10 to power minus 7. Instead of farad, one can write ampere second volt and second, okay, into volt, okay. So ampere volt square. Now we have to multiply 55 into 23. So after solving, it should become 1265, okay, 0.5 micro, okay. If we put 10 minus 1, so it's after solving it will come micro ampere per volt square. We have already solved this one, 126.5 micro ampere per volt square, okay. So this will be nearly 127 micro ampere per volt square. So this one is the K and S value. It is coming 127. This will simply we can calculate. I have already calculated, so I am directly writing the value. So now the second part is almost over. So now the third part is we have to find out the overdrive voltage, okay. We have to find out the value of overdrive voltage, okay. So overdrive voltage, okay, that is our VOV is VGS minus VT. And for this calculation it is given the transistor is in the saturation region, so ID in saturation. So it should be uh, formula we have to write 1 by 2 K and S W by L VGS minus VT whole square. This one is the standard formula for the drain current in the saturation region. So in the question it is clearly mentioned the drain current value is around 0.2 milliampere. So I am directly writing it should be 1 by 2, and K and S we have calculated 127 micro, so 10 to the minus 6 ampere per volt square, into W by L is also given 20, I think 20, okay. So simply multiply with 20 VGS minus VT whole square. So okay, so now what we can do, we have to solve this one. So what we can write 0.4 into 10 to power minus 3 divided by 127 into 20 into 10 to power minus 6. Simple calculation, VGS minus VT whole square. Now again I am solving here, okay. So what we can, okay, or we have to write here VGS minus VT whole square equals to 0.4 into 10 to power 3. If this one go up, so 10 to the power 3, then 254 into 10, or we can remove this one. So better to write 4 by 254 into 10. So 40 by 254, or 20 by 127, okay. So this 20 by 127 is coming. So if we solve this 20 by 127, it will come 0.157, okay. So the value of VGS minus VT whole square is 0.157, okay. So the overdrive voltage is nothing but simply VGS minus VT. So it value will be square root of 1.57. So if we solve, it will come nearly 0.4. So overdrive voltage VGS minus VT value will be 0.40 volt. So this one is the question, means in problem they have asked to find the value of VGS minus VT, okay. So we have already find the VGS minus VT by using the drain current equation, because everything is given. So Now one more thing, we have to find the minimum value of VDS. Okay, the last problem was minimum value of the VDS. Minimum value of VDS. Okay, or in general can say VDS mean for in which the transistor is in the saturation region. Okay, so for this thing we have to very careful about this diagram, and if we know this diagram, okay, VGS minus VT, and this point is a VDS minimum. After that the device in the saturation, and below this point it is in the linear region. So VDS mean is simply our VGS minus VT, that is our overdrive voltage. That is, so simply one can write VDS mean equals to 0.40 volt. So this one is the VDS mean value, which is just this point. Okay, this point. Okay, so this is all about this question. So in the problem, it's very simple. We have to find every value, so we can easily find by using the mm, basic concept of network that means MOSFET circuits. So this is all about this question. So thank you for watching this video.